All right, so here is an instructional video for how to perform the lab. In order to do this lab, you're going to need a low voltage power supply. That's this guy right here. He's got an on-off switch. He's got a dial that lets you turn the voltage up from 0 to something about 12. And then there are many places where voltage comes out. This is a grounding wire, and then these two, the red and the white, are the ones you're going to use for your power. Think of this as the positive terminal of a battery, and this is the negative terminal of a battery. By the way, these things are pretty old, and so the first couple of notches from 0 to 1, or maybe even over here at what would be like 9 o'clock, it doesn't work that well. So you don't want to start at 0. Well, I guess you could have 0 as one of your values, but then your first other value of voltage is going to be way over here. Keep that in mind. The other equipment you're going to have is you're going to have a digital multimeter, which is going to be used as a voltmeter, and you're going to make voltage readings by touching the probes to the either side of the resistor. And then you're going to have an analog style DC ammeter. And this has many inputs. You always use the black one that has the negative terminal. And then with the other inputs tell you which scale you're using. 50 corresponds to the maximum current being 50 milliamps. 500 means the maximum current is 500 milliamps, or half an amp. And 5 means the maximum current is 5 amps. If you're measuring very small numbers, you could use the 500, but if for most of the experiment, you're going to use the 5 because we might be seeing voltages that are in the single-digit volts. Then the bag of equipment contains a number of other pieces you might need and you might not need. There are 3 of these alligator clips. These are used for making connections to things that don't have these special posts that you can plug the banana plugs. That's what these are called, banana plugs. You can just slip one of these over the end of a banana plug and it becomes an alligator grippy type thing. This is great for holding on to the resistor, so we'll put these to the side. Then there's going to be a pair of resistors. This one, it's in a bag, is a 10 watt 36 ohm resistor. Let's see if I can get that to focus. Printed right on there, 36 ohms. And this one right here is a 10 watt 10 ohm. Okay, I could take this out of the bag. 10 ohm resistor. So those are our 2 resistors. And yeah, let me take these out of the bag and put them to the side as well. Resistors have a wire coming out of each side, and so you clip up your alligator clips to these wires, and then when the flow of current goes through this magical white box, it is resisted in its flow. Put the equipment to the side here. When you do this experiment, the resistors are basically just resisting the flow of electricity, but as a byproduct, they make heat. So they might get warm. So it's a very good idea to turn the current on when you're making a measurement or making changes. Turn it off when you're just sitting there talking or writing something down. That lets the resistor cool off a bit. The other thing in the bag is 5 wires. 5 wires with those banana plugs at the end. The color of the wires is completely immaterial. I'm going to spread these out because they have a tendency to mate when you leave them alone. That way I can get them one at a time. Let's get our voltmeter out of the way. Ooh, let's talk about the voltmeter for a second. We're going to set the voltmeter to measure voltages going from 0 to about 12 volts. So you need to find, if it's not an auto-ranging voltmeter, you need to find the section that has the DC voltage. That is not the wavy line voltage, but the other volts. And you need a setting that goes up to about 12. So 2 volts is not going to cut it. We're going to go for 200 volts. Now it's ready to measure up to 200 volts. Okay, putting that to the side as well. We need to build the circuit. And I'm going to do all of this while the power supply is off. That's an important safety instruction. So we're going to start, and I've got a red wire for reasons unknown. It's connecting up to the positive terminal of the power supply and to the 5 setting here on the DC ammeter. Okay, from the ammeter, we're going to go to our resistor, and I just happened to grab another red one. We're going to go from the negative of the ammeter, and we're going to go to our resistor. So I'm going to put an alligator clip on the end of this, and we're going to get started with the 10 ohm resistor, I think. So I'm going to clip that up right here. Now, although this does not look like a schematic, we are going from the power supply to the ammeter, from the ammeter to the resistor. So we only need one more wire. And why the heck not? Let's use a black colored wire. And we're going to go from the other side of the resistor back to the power supply. So we go from the other side of the resistor back to the power supply. Now this creates a circuit. We can trace it. We go to the ammeter, through the ammeter, to the resistor, and from the resistor all the way back home. It's a great circuit. Really important when you make this circuit that these 2 points don't touch each other. The only resistance in this circuit is this resistor. If these two touch each other while the power supply is on, we could burn out the ammeter or burn up the power supply. It is a danger, and it should not be done intentionally. And one way to avoid that, of course, is turning everything off when you're making adjustments. This way they can't touch because I've angled the clips away from each other, and they're very well clipped onto these metal leads. And it's sitting right in front of me. How very nice. Now the thing that's missing here is when I turn this on, we're going to see some current flow. Let me put the power supply to the middle, and we turn it on, and you can see right away we get some current flowing. We've got nearly an amp of current flowing. You could read that. I think it's 0.8 of an amp. Turning it off to let everything rest. But we don't have the simultaneous voltage measurement, and that's where the voltmeter comes in. I'm going to need to tilt this over a little bit, maybe do this. There we go. Put the voltmeter right next to the ammeter, and I've got the two leads for the voltmeter, and it doesn't really matter which one I touch to which side, but I'm going to be color coordinated here, and I need to touch these leads on either side to measure the voltage. So let's turn this circuit back on. We see our nearly 1 amp of current, and we hold this down, and we see that we've got 7.8 volts. That is one data point, 7.8, 7.9 now volts, and 0.8 amps. I would write that down. Turn off the power, let everything rest. Is this guy hot? He's a little warm. Okay. If you don't want to touch this each time to get your reading, hey, why don't you be clever and find some way to stick the probes in with the alligator clips. Just make sure that the probes don't touch each other either. Now that's a pro arrangement right there. Okay, so I had the one value. Let's crank this down, and we'll turn it on, and we're going to see a small amount of current here. Looks like about 0.3 amps and 2.7, 2.8 volts. Turn that off. And that's all you have to do is you have to make 10 different measurements around this power supply. Oh, let's find out what the maximum is. Okay, maximum. Maximum gives us 1.1 amps and 10.8 volts. Turning it off. Okay, so this is best done in pairs so that one person can make the arrangements and the other person can write the stuff down. 10 different voltages with 10 different currents, and interpolate between the lines. I happen to have been lucky if I saw 3 and 0.8 amps, but if it was between 0.7 and 0.8, I could call that 0.75. Also, if the last digit on the voltmeter is fluctuating, it's your choice which digit you want to write down. Once you've measured one of the resistors, make sure the power is off. Unclip that resistor out of the circuit and substitute it, yeah, that's a little warm, for the other resistor. This is the 36 ohm resistor. And get everything back. So good clip on this side. Good clip on that side. Looks like we're ready to go. I'm set at max. Oh, what the heck? Let's just check it out, see what happens at max. At max, well, okay, we have much less current now. That's between 0.3 and 0.4 amps, and we have 11.9 volts. Oh, up to 12. So that's the one reading for that one. If the number of amps gets really small, remember that when you put it in the 500, if it gets below half an amp, we could switch over. Now these are not getting below half an amp. I could maybe get below half an amp. I don't think it's going to be necessary to switch over to the other input, but you could switch over to the other input. At this setting, it was pretty low, so I could switch this to the other input, and you would see that no, that didn't seem to make much difference at all. Yeah. No reason to switch, everybody. This is the arrangement. I want you to do one resistor. I want you to do the other. As an optional added bonus, and I think maybe I am going to require this. This is not warm at all. What would we do if we wanted to put these two in series? Well, to put these two in series, we could use a spare alligator clip to clip the two resistors together. Then we could clip up to one end of the combined resistor and the other end of the combined resistor. Let's get our probe situated inside the jaws of the alligator clip. And then we could do this one. Here we are at half power, getting a very small 0.2 amps on the ammeter and 8.7 volts. And this is a series arrangement. Again, turning off the power when not in use. Very good for the equipment. I used to do this experiment with much higher values of resistance, which kept the current very low. It meant that I had to use a more finicky piece of equipment to measure the current, but there was not really much danger of blowing the power supplies. The more finicky piece of equipment, however, had a fuse in it that if you accidentally touched these things together, it would blow, and I'd be constantly replacing fuses. This, although there is the danger of things heating up, particularly when you're using the 10 ohm resistor, this is a much simpler arrangement to let you verify Ohm's law. So what you're going to do with this data when you have 10 values of current and voltage is you're going to plot them on an axis where the, let's see here, the x-axis is going to be voltage. I'm sorry, x-axis is going to be current, y-axis is going to be voltage, and all the data should be a straight line. The straight line the slope of that straight line should be the resistance. And that's the lab. I'll hand you a paper on Thursday or Friday, and the equipment will be out, and you'll be able to do the lab. Keep in mind that in the classroom here, the only plugs I have are at the edges of the room. So I'll set up a table in front near a plug. There will be 6 other plugs available for people to do the experiment, and I'll try to clear an area in the back and have one group back there. So that's a grand total of 8 plugs. Maybe I'm going to try to do 9. I've got enough desks. We can move this around. I'm going to try to get 9 stations going. 9 stations with 2 kids to a station works out to be, what is it, 18 kids. That's about right for most of my classes. As far as the distancing, social distancing, you can still do that as much as possible. And if you have one person working the equipment and one person recording the data, they don't need to be sitting right next to each other, although the person recording the data should definitely have a look at this and maybe, you know, have some advice on building it. That's all I need to say right now. Didn't even use these 2 wires over here, but some people will if they use a different voltmeter, one that plugs in. They could use these 2 wires to connect the voltmeter. Oh, one more thing about these banana plugs. They have this really interesting situation here. If you need to connect 2 banana plugs together, there is always a hole in the back or the side of the banana plug that allows you to slip one banana plug in the other, and they make a connection. So that's a really useful thing if you ever need to make a wire longer or something like that. All right, I've talked for too much. That is how to do the Ohm's Law lab. The results turn out really well, and we'll talk more about it in class.